Hello everybody, this is Jeff Janess and welcome to lab exercise number 12 on raster analysis. And here we're going to look at an interesting way to generate a hillshade based on multiple sun positions. It's one of the Swiss method modifications to hillshades that makes them more visually interesting. And this one can help bring out topographic details that are lost or kind of get washed out in a simple hillshade. Now, in our last lab, we looked at how to create a hillshade from multiple sun angles by simply generating multiple hillshades and adding them together. But in this exercise, we're going to weight each hillside by how directly it faces the sun. So this particular method is called the multi-directional oblique weighted hillshade, which we discussed in our third lecture video for this module. It's first proposed by Robert Mark of the U.S. Geological Survey back in 1992. So let's first review how this method works, and then we'll actually generate the hillshade later in the video. Now, MDOW uses 4 illumination sources, and then it weights the strength of that illumination based on how directly the landscape faces it. Interestingly, it gives the illumination the most weight when the landscape is facing perpendicular to it, and the least weight when the landscape is facing directly toward that sunlight. Thus the name oblique weighted. And you can see the weighting system in this graph. The direction values here don't mean compass direction, but rather how directly the landscape faces the illumination source. 0 degrees means the landscape is facing it directly. And you can see that the weight applied is 0 at this point. The illumination is effectively turned off if the landscape directly faces the source, and dialed up as the landscape turns away from it. So the strength of the light source is maximized when the landscape is at 90 degrees counterclockwise and 90 degrees clockwise to the light source. When generating an MDOW hillshade, you specify the general illumination direction, just like you do in a normal hillshade. Then the MDOW algorithm arranges the 4 MDOW illumination sources around that primary direction, spaced at 45-degree intervals. You essentially generate 4 separate oblique-weighted hillshades. And in this graph, we set the 0 degrees to be the direction of the general MDOW illumination source, and the first light source is set at 67.5 degrees counterclockwise from the primary direction. Weighting scheme for the first light source is distributed like this. Then we add a second light source centered at 22.5 degrees counterclockwise from the primary illumination direction. This is 45 degrees from the first light source, and these weights are distributed like this. Then we add a third light source at 22.5 degrees clockwise from the primary source, and finally the fourth light source at 67.5 degrees clockwise. Now, here we go. This is another example where a standard Cartesian graph doesn't really show the circular nature of the data, so we usually present this as a circular graph, similar to the rose plot graph we saw earlier. And here we see the primary direction of the light source, the direction of the 4 MDOW components distributed around that primary direction, and the weighting factors for each component. The graph's a little confusing the first time you look at it, but it's pretty cool once you realize what it's saying. But the basic steps are that we first generate 4 hillshades from these 4 directions. We multiply the hillshades by these weighting factors, and you get the weighting factors by calculating the deviation of aspect from the direction of the hillshade. Then you take the sine squared of that, which basically means to subtract the hillshade direction from the aspect value, take the sine of that, then square the sine. So now you got a raster of weight values for this hillshade. Multiply the weight raster by the hillshade raster for each of the 4 hillshades and add them up. Now we're going to get into how to make this hillshade in just a sec, but I also have a version you can download if you like. It's available in this lab exercise document. There's a little link here. This link's also available in the descriptive text underneath the video. Anyway, you download this. It'll take you to a geodatabase that has a toolbox in it, this one here, and there's an MDOW tool already available. Nice thing about this version is that I set up some model parameters, so all you have to really do is just double-click on it, and it'll open it up, and you can set the parameters and run it. Another nice thing, though, is that you can right-click on it, go to Edit. You can actually see how the model's set up. So this is a working version of the model. If you'd like to use this as a reference, or maybe just get in and play with it and edit it, you can do all that here. So feel free to download that if you like. Okay, now in this lab exercise, I'm going to be using ArcGIS Pro version 3.3.2, so the tools might look a little different if you're using a different version of the software. Now, first, like this is going to be in a model. This is not a process you would want to do by setting up a bunch of tools and running them manually. So let's go to our toolbox. You can make a new toolbox if you like. There's lots of good reasons you might want to do that. I'm just going to use the default toolbox that comes with my project, and you will have a default toolbox as well. So just open that up, right-click in the middle, go to New Model, and now we have a new empty model ready to work. Now let's set this aside. We're going to start adding stuff to that. Let's also get our map set up so when we run the model, it'll apply right directly to that map. We have a new map. We're going to add a data set from the class data folder. So you come in here. The data set we're looking for is in raster functions. It is DEM, a little 10-meter resolution DEM near Flagstaff. So we're just going to add that to our map. All right, so this is the DEM that we're going to create the hillshade for. Now, back to our model. We have an empty model here. Let's set a couple properties for it. Let's set a name for it. We're just going to hit this little button here to do properties. The name is just going to be MDOW, multi-directional oblique weighted hillshade. The label, we can have a more elaborate name. Let's give it something that actually says something. All right, hit OK. So the model label here is changed. I'd like to have this little toolbar here available in the model just because the tools are quicker to get to. You could also come up here and find them in the ribbon if you want. But for now, let's just work out of this little toolbar here. Okay. All right. So first step is to, well, a lot of this is based off of the DEM and a lot of is based off aspect. So it's oblique weighted. Well, the weighting is based on aspect. And there's going to be 4 weighting rasters that we come up with. First thing we've got to do is get in the aspect raster. So let's just go to the tools. We're going to search for surface parameters. And we're going to use a spatial analyst one. This is assuming you have spatial analyst licensed and turned on right now. Just drag it into the model. By the way, a common mistake people make is they just open the tools and they just double click on this. That's not what we're wanting to do. We're wanting to actually drag it into the model and construct it down here. All right, so let's get this out of the way. If we double click on surface parameters, it opens up the window where we can set it up. The input raster is going to be our DEM, and it's reading that from our active map here. The output raster, we're going to call it temp aspect. It's not going to have a mask. The parameter type is going to be aspect. Surface type quadratic is fine. This is just the cell size of the raster. That's fine. I happen to know that the raster is in meters, so I want the Z unit to be in meter. I also happen to know that the raster is projected into a meter-based projection, so that's helpful in this case. All right, hit OK. Our model is starting to come together. Now, next step is to build a hillshade and weight that hillshade according to the aspect. And as you saw earlier, the weighting system is pretty creative and interesting, but not really straightforward. So what we're going to do is we're going to set up all the tools to do one weighted hillshade. Then we're going to copy that set to do the other 4. And so let's just start with the first one. We want to add a minus tool, a times tool, a sine tool, a square tool, a hillshade tool, and a second times tool as well. But let's start with these 4 here, get that string built up. So we're going to do a minus tool, spatial analyst, just drag that in. We're going to do a times tool, spatial analyst. We're going to do a sine tool. Here we go. And we're going to do a square tool. So we get the sine squared. Okay. Okay, now we want to create a raster that's a deviation of our 4 directions. And remember, our first direction is going to be at 247.5 degrees. So we want to subtract 247 from aspect, and that'll give us a deviation from 247. So we start by just connecting aspect to the minus tool. We just draw a line. When we let off on the cursor, it asks us which parameter we want it to be, so we're going to use the aspect as constant 1. We double-click on minus, so it's getting aspect as the first value, and the second value we're just going to type in 247.5. We want to name our rasters that the tools create, so let's give them all names that make sense. So this is -1, meaning this is minus along the first weighted hillshade. So we're gonna just keep a consistent naming system. This produces a raster that tells us the deviation from aspect in degrees, but we want to convert that to radians because the sine tool expects radians. So we're just going to connect minus to the times. This will be the first raster. Now the conversion factor for radians is right here. So we're just going to copy this value. So let's double click on times. The first item coming in is this raster here. We're going to convert it to radians here by multiplying it by that value. And we're going to call this value, this raster, radians along the first weighted hillshade sequence. All right. Now the radians, we're going to take the sine of that. So we just drag this in here, make it the input value. We want to change the output name here, so we can just double click on this. This is going to be sine along the first sequence. Hit OK. And then we're going to square that. And let's change the name of this to square along the first sequence. All right. So we're on our way. Let's kind of clean this up a little bit. I'm going to hit Auto Layout. It just kind of puts it in a straight line for us. Okay, now let's get the hillshade in there. Let's type in hillshade. Spatial Analyst, come down here. And the hillshade is going to be based on the DEM, so we're going to drag this down here, connect it up. It'll be the input raster. Set some parameters here by double-clicking on that hillshade process. Remember, the direction is going to be 247.5. The output raster, we're just going to call it hillshade 1. Okay, that's set up to go. Now we have a hillshade and we have a weighting factor here, so we just have to multiply those two together using the times tool again. Down here, okay, hillshade will be input raster 1. The weighting vector over here will be number 2. The output is, we're just going to call it weighted hillshade 1. Okay. All right. Now we've got our first weighted hillshade set up. Let's kind of clean up our layout a little bit. So this is the first one. We have to make 4 weighted hillshades. So we can do this a little bit easier by just copying everything from minus forward. So everything downstream from this. And we can just select them, copy them, just right-click and do copy. And then you can hit Control-V or you can right-click and do paste. Either one will work. All right, so we got a whole bunch of copied functions and processes here. Notice that we still have, they also copied in the connecting links, so that's a good thing. So we got this one, we're going to copy it again. I'm going to hit paste again. Now we got another one here. Just kind of get that out of the way a little bit. And we're going to do one more because we need 4 of these. Okay, I'm just going to cover up our Word document here just because I want you to be able to see this a little bit better. All right. Okay, so we got 4 sequences here. This is the original one up here, but now we got to edit the copies. We have to edit in a couple ways. First off, we have to edit so it's dealing with the right direction. So, and remember this one here subtracted 247.5 degrees. The next one we want to be a different bearing. This one will be 292.5. All right, and we want the output raster to be -2, meaning this is the minus on the second sequence. Okay, hit OK. All right, so that's set up. Now the times, this is set up correctly. We have the right value we're multiplying it by. We just need to change the output to radians 2. We'll take the sine of that, so we'll change the output name of this to sine 2. Okay. Square is fine, but we need to change the name of the output to square 2. All right, now let's come up to the hillshade. The hillshade we also need to adjust to be 292.5. We're going to change the name of the hillshade to hillshade 2. Now we have times, and here is the weighted hillshade of the second sequence. We're going to call it hillshade 2. And by the way, if you're curious, the reason we're making sure that every intermediate data set has its own name is that if we don't, then they wind up getting overwritten by other parts of this process, and sometimes that can mess up the final product. All right, so now we have the first sequence figured out. We have the second sequence all working. Now let's do the third sequence. On the third sequence, we come to the minus. This one's going to be based on 337.5 degrees. Okay, the output raster, since this is the third sequence, we're going to call it -3. We're going to multiply that by our conversion factor here to get radians. So let's change the output name here to radians 3. I'm going to take the sine of that. The output of the sine will be sine 3. Take the square of that. The output of that will be square 3. The hillshade, we have to change the hillshade sun position again. So this is 337.5. The output will be hillshade 3. Multiply that to get our weighted hillshade, and we just have to call this weighted hillshade 3. All right, so now our first 3 sequences are set up. Let's just do the last one. Minus here, this one's going to be -22.5 because that's our fourth direction. Oops, let's put a period in there. The output name will be -4. I'm going to convert it to radians here, so the radians will be radians 4. Take the sine of that, we're going to call that sine 4. The square of that, we'll call it square 4. Hillshade needs to be adjusted so it's at 22.5 degrees. We're going to call this hillshade 4. We're going to multiply that by our weighting factor to get our weighted hillshade number 4. Okay, now we've got our 4 weighted hillshades set up. So let's clean it up a little bit. Auto layout. Okay, here we go, our 4 weighted hillshades. Last step is to add them up and then divide the sum by 2. So we can do all that in the raster calculator tool. Right here, we just drag it down here. Now I have the calculation string here in the document if you'd like. It's right here. You can copy and paste this if you like. I'm just going to build it properly. So you just double click on it. We have 4 rasters we're going to add up. And the first sum should all be in parentheses. So I got to open parentheses there. Let's come down to weighted hillshade 1 plus weighted hillshade 2 plus weighted hillshade 3 plus weighted hillshade 4. Close parentheses, then divide the sum by 2. We're going to call this MDOW. All right, and there we go. And notice as we do this, it connects up the weighted hillshades. It builds those lines that run right in, so that's kind of cool. Let's hit Auto Layout to clean it up again. All right, so this should be ready to go. We just hit the Validate to test it. It doesn't find any obvious problems. Now we're going to run it on this raster here. To run it, you just hit the Go button here. We'll watch as it goes through its different pieces. And voila! Let's close this down. Now, it's supposed to add it to the map, but it doesn't always. I'm not sure what Model Builder has in mind sometimes, and save our edits to that. So since it didn't, let's just go to our database and add it manually. Here it is. Just add it to the map. And by the way, notice all the other data sets in this geodatabase. These are all the intermediate rasters that the model generated in order to create that final MDOW hillshade. And if you don't want to save all these intermediate data sets, then I'll show you how to get rid of them in just a second. Anyway, we've added this MDOW raster to our map, and here it is, our multi-directional oblique weighted hillshade. If we come back to our model here, let's edit that. It has this delete intermediate data sets. If we just hit that, it'll get rid of all that intermediate stuff that the tool created. All these 25 data sets it created, all these green circles in the process of making our final data set. Let's come back to our database, MDOW, refresh that, and notice all we're left is the single data set. It deleted the intermediate stuff. And there we go. All right, that's all there is to it. Thanks so much for watching, everybody. We'll see you in our next lab exercise. Y'all take care. Bye-bye.